Okay, we're back with our example problems, and our first one is an example of a block on an incline. And so we can see that we've got our block here. It has a mass of 13 kilograms, and it is being pulled up the incline with a force that's equivalent to 150 newtons. We do have a coefficient of friction, and we do know the angle of the incline. And so the question here is, what's the force of friction? So how much friction is applied? And what is the net force that the block is moving with? So if I look at this and I draw my free body diagram, because that's the first thing I always want to do, is I actually put my point right there, and I draw my force due to gravity down. I know that I have a force here that's acting at 150 newtons. And let's see, if I have that, I must have also a normal force. And then I have a frictional force. Okay, so these are all the forces that are acting on my box as I'm pulling it, okay? Now, ideally, what I want to do is I like to set up a system of coordinates. And so I want to make this direction right here the x direction, this direction the y direction. So I'm actually going to look at my angle, or my incline as the flat spot. It's the x direction, and then everything perpendicular to the angle, or to the incline, would be the y direction. I'm going to split this up into components because I want to find my force parallel, or I should say perpendicular. And I also want to find my force parallel. Now what happens here is the force of friction and the force parallel are actually the two that are acting in the same direction, where my pulling up is the other part. So I've got that. I want to figure out what the weight of the object is. So what is the weight of the object? And then I'm going to figure out each of those. Now again, my angle is right there, so that's my 23 degrees. Okay? And so now I'm going to switch into a different color here. I actually want to work on a solving color. So I'm going to pick blue today. My gravity causes my mass, 13 kilograms, times my 9.8 meters per second squared, to give me my total force. Okay, I'm going to grab my calculator. 13 times 9.8 gives me 127.4 newtons. Now, my force parallel is going to be the cosine part of that, so it's going to be 127.4 times the cosine of 23. So in other words, it is a 117.3 newtons. And my force parallel is the sine portion of that. So in other words, 127.4 sine of 23. Or 44.8. Or excuse me, 49.8 newtons. So now I know my force parallel, and I know my force of perpendicular. Now my frictional force, okay, to find my frictional force, blue is not too good. Let's switch colors here. My frictional force is equal to a coefficient of friction times a force normal. Okay? Now the force normal is actually equivalent to my force perpendicular. And the reason why is because my box is not moving in this direction, so it's the object at rest stays at rest. Okay, and so my coefficient of friction is 0.399, and my force normal is equal to my force perpendicular, and my force perpendicular is 117.3 newtons. So my frictional force is now 117.3 times my 0.399, and that comes out to be 46.8 newtons. Okay? And so now I have my frictional force, 46.8. I have my force parallel, 49.8, and both of those forces are equal then to my force going the opposite direction. So the sum of all my forces is going to be, okay, so I found my frictional force. That was one of my questions. What's the net force? My force net is going to be equal to, and now this is in the x direction, okay, is equal to my 150 newtons minus my friction force minus my force parallel. Okay. And so I'm just going to do this now. I'm going to take my 150 minus my 46.8 minus my 49.8, and so I have a net force of 53.4 newtons. Okay, and so that's my net force as we're pulling this block up the incline. Okay, and I can see that I'm going to have to pause here. Okay, so here we have our second problem. And our second problem now is one in which we're looking at pulling a box. And let's see, might be experiencing some technical difficulties. I think I'm going to do the second problem as a second video. All right.